Hello students, welcome back to the first video of this new playlist. So in this playlist I'll be solving June 2024 Statistics 2 paper. So in this playlist you will see questions like in each of the videos of this playlist I will solve each of the questions from this June 2024 Statistics 2 paper. So since this is the first video, so in this video I'll be showing you a detailed solution with clear explanation of the first question of this S2 question number 1. So let's get started. Okay, so the first question, number 1. Basically, if I give a review on question number 1, basically chapter number 1 is from a mixture of different concepts. Like you should have idea about Poisson distribution, you should have idea about binomial distribution, you should have idea about approximations, and also you should have idea about hypothesis testing. So basically this is a combination of concepts from 4 of the chapters. I'm talking about the whole question. So in order to be able to solve this question, okay, or if you should understand this solution, then definitely you should have finished chapter number 1, that is binomial distribution of your S2 book. Then chapter number 2, that is Poisson distribution from your statistics 2 book. And then chapter number 3, that is approximations, and at last chapter number 7, that is hypothesis testing. So you need concepts from these 4 chapters in this question. So let's get started. Number 1. So what they have said in number 1, a garage sells tires. Okay, the number of customers arriving at the garage to buy tires in a 10-minute period. Okay, it is what? 10-minute period is modeled by a Poisson distribution. They have already given that it is what? Distributed with Poisson distribution, and its mean is what? Here the lambda is equals to what? The lambda is also equals to what? 2, right? The mean is given as lambda, it is equals to what? 2, right? So you can easily understand this is what? Poisson distribution. Okay, so the first question asks here, find the probability that fewer than 4 customers, what? Fewer than, that means less than 4 customers arrive to buy tires in the next 10 minutes. Okay, so let us consider some concepts of Poisson distribution. For Poisson distribution, what we know? We know that for Poisson distribution, the outcomes occurs at a mean rate, which is lambda, right? So we will consider here x is distributed with Poisson distribution with mean what? 2. What is x there? Basically we will explain x as the number, it's the number of customers arriving, okay, the number of customers arriving at the garage in how many minutes? 10 minutes. Okay, in 10 minutes. This is the variable x. Fine. Now they wanted the probability of x. What? Probability in part 1 they have asked for probability of x less than fewer than 4, right? So x less than 4 can be written as what? X less than, this is discrete. Remember, Poisson distribution is what? Discrete distribution. So in that case, probability of x less than 4, that means x is like x cannot be 4, and less than 4 is what? Less than x less than or equal what? 3. Fine. So how can you get the value? You can get the value by using the Poisson distribution table. Let me show you. I have the copy of this formula booklet. Okay, here is it. So at first, from your formula booklet, you need to go to at first the Poisson distribution table. This is binomial. you will go to Poisson distribution. Look, this is Poisson. Okay, this is for Poisson distribution. Okay, so we know that the value for lambda is what? 2. I'm just showing like how can you follow through the formula booklet, because in statistics 2 you should use the maximum use of what? The formula booklet. So it is very important to know how you can use the 100, how can you make the 100% use of the formula booklet. Okay, so lambda equals to 2. Here you can see this is 2, and we need x less than or equal 3. This is x less than or equal what? 3. And how do I understand that? Look, if you see here the probabilities, the x values, here you can see these x values are basically showing probability of x less than or equal small x. So basically it is a cumulative distribution table. That means it is giving you the cumulative probabilities, the sum of the total probabilities. That's why this is x less than or equal what? This is x less than or equal 3. Okay, so 0.8571, we got 0.85 what? 71. Okay, we got 0.8571. so this is what? 0.8571. so you can give it the answer to 3 significant figure, that is 0.857, that is up to 3 significant figure. Okay, next, part 2. In part 2 what they have asked for? Okay, in part 2 they have asked, we need to find out the probability that more than 5 customers arrive to buy tires in the next 10 minutes. Okay, more than 5. Okay, okay, more than 5. Okay, more than 5. So probability of x greater than 5, it is what? It is equals to greater than, so it should be what? 1 minus what? We need to convert the greater than into a less than or equal. Why? Because the table that we have, it is given in less than or equal form, so we need to represent it in the form of probability of x less than or equal what? 5. Okay, so if you subtract probability of x less than or equal 5 from 1, you will get the probability of x what? Greater than what? 5. Okay, so let's see. Okay, so x greater than or x less than or equal 5, we need x less than or equal 5, right? Lambda is 2, so follow through the previous lambda. 0.9834, this is what? 0.9834. okay, so this is 1 minus what? 1 minus 0.9834. so what would be the value? Use your calculator. 1 minus 0.9834, that is 0.0166. okay, 0.0166. that's the answer to 3 significant figure. Okay, that's it, done. Next, for part B, let's see what they have asked in part B. The manager randomly selects 20 non-overlapping 30-minute periods. Very important to understand. Okay, it's very important to understand 20 non-overlapping, that means 20 independent 30-minute periods. Okay. Okay, sorry. So earlier the mean that is given, that is 2, it's for what? 10-minute period, but now the mean is 30 minutes. So we know that for Poisson distribution, the mean basically depends on the on the what? Period, on the period, or the on the size, isn't it? So for 10 minutes it was 2, that means for 20 minutes it will be twice, right? Because 20 is twice of 10, that means the mean will be twice, that means 4. Now if it is 30 minutes, that is 3 times of 10 minutes, that means the mean will be also what? 3 times, that means we need what? 6. The lambda would be, in this case, the lambda would be what? Okay, the lambda would be, in this case it would be what? Lambda would be 6 here. In this case, lambda equals to what? 6. Okay, now you need to understand a bit concepts here. Basically, in part B, basically the part B here, you can see this part B is like mixture of both Poisson and binomial. Okay, like they asked find the probability that there are between 4 and 7 inclusive. Okay, 4 and 7 are included. That means greater than or equal or less than or equal it would be. So there are between 4 and 7 inclusive customers arriving to buy tires in exactly 15 of these 30-minute periods. It's a bit tricky. Okay, it's a bit tricky. We need to consider, look, this is the number of customers that is arriving. It is distributed Poisson, but the number of samples, this is what? Binomially distributed. How did I understand? We already know that the number of customers arriving, this is happening at a mean rate, right? And the manager took 20 non-overlapping samples. That means the number of samples, it's fixed here, right? It's fixed here. Since it's fixed, that means it is what? It is distributed binomially. Okay, the number of the samples, 30-minute period samples that has between 4 and 7 customers arriving to buy tires, it is what? It is distributed binomially. The samples are distributed binomially, but the number of customers arriving, this is distributed Poisson. Okay, so we will consider two variables here for part B. Okay, we are done with this part. For part B, what we can say? For part B, okay, so for part B, what we can say? For part B, consider the variable y. Y is what? I will tell you definitely. Lambda is 6 here. Okay, so what would be y? Y is basically the number of customers arriving at the garage in how much time? In what? 30 minutes. Okay, this is a different what? Variable. This is what? Variable r, sorry, variable y. Okay, so what we can say here, we need to find out the number of they said number of customers. We need to find out the probability of customers, that is like the probability of number of customers arriving in 30 minutes. It's between 4 and 7. That means we need probability of what? Y greater than or equal 4, okay, and less than or equal what? 7, inclusive. That's why. So it would be what? Probability of y less than or equal 7 minus what? Minus probability of y less than or equal what? 4 is included, so it would be what? 1 less than that. Okay, so what would be that probability? Let's check the distribution table. Okay, so now okay, now the lambda has been changed, so we need the value for lambda for 6. Lambda equals to what? 6 now. So lambda is what? 6 here. So we need to consider lambda equals to what? 6. Look, where is lambda equals to 6? Look, this is lambda 6. Okay, so we need probability of y less than or equal what? 7 at first. 7. This is what? 0.7440. Okay, we got 0.7440. 0.7440. So 0.7440 minus what? Minus, it would be, just check it from the table. Okay, we need probability of y less than or equal 3. Less than or equal 3. This is nothing but this one. Look, 0.1512. Fine. Okay. So what would be there? 0.1512. So what would be the value? 0.7440 minus 0.1512. Okay, this is what? 0.5928. This is 0.5928. So you can write, okay, use exact value since this is not the final answer. So probability of customers, the number of customers arriving in the garage in the 30 minutes period is what? Between 4 to 7. Its probability is what? 0.5928. Now we need to find out of 20 samples, how many out of 20 samples, we need to find out the probability of 15 samples to have the number of customers arriving at the garage is 4 to 7 in what? 30 minutes time period, right? So this is a new variable that is considered z. Okay, it's distributed binomially with how many? 20. Number of samples is 20, right? And probability of having like 4 to 7 what? Customers arriving at the garage in the next 30 minutes. Okay, so this is what? The distribution of what does the variable z represents? The number, it represents the number of what? It has how many samples there? The number of 30-minute period samples. 30 minutes period sample which have number of customers arriving to buy what? To buy tires. The number of is between what? 4 and 7 inclusive, right? 4 and 7 inclusive. So we already know the probability of a sample to have the number of customers buying tires, arriving the garage to buy tires in the next 30 minutes between 4 and 7. If it is what? Between 4 and 7, this probability is what? 0.5928. So we need probability of z. How many they wanted? 15, right? So this would be what? 20 choose 15 binomial, right? Times what? What's the probability? 0.5928 to the power 15, right? And times what? 1 minus 0.5928 to the power what? 5. So what would be the value? Let's figure out the value. 0.5928 to the power 15 times 1 minus 0.5928 to the power what? To the power 5 times what? 20 choose 15. So this is 0.0681. 0.0 what? 6809. So we will round to 3 significant figures. 681. This is up to 3 significant figures. That's the answer. Understand? This is both binomial, Approximations-Poisson, and then it's what? Binomial. That's it. Okay. What's next? Part C. Okay. The manager believes that placing an advert in the local paper will lead to a significant increase, look, significant increase in the number of customers arriving at the garage. Okay. A week after the advert is placed, the manager randomly selects a 25-minute period and finds that 10 customers, how many customers? 10 customers arrive at the garage to buy tires. Okay, this is the outcome of the statistic, and the manager, he is doing the what? Test on a 25-minute period, what? Sample. Okay. So, part C, test at the 5% level of significance. The level of significance is how much? 5%. Okay. Whether or not there is evidence to support the manager's belief. Okay, we need to do hypothesis testing in this case. Okay. How can we do the hypothesis testing? Okay. For hypothesis test, the first step is to what? Is to consider the null and the what? Alternative hypothesis, right? So in that case, what would be H0 and what would be H1? How can you figure it out? Look, H0 is always the proportion or the mean that is already existing. Okay, so here the existing mean is what? Lambda equals to 2, right? The initial, you will consider initial lambda equals to 2, because if lambda equals to 2 changes, then lambda equals to 2, it's for what? 10-minute period. So if the mean of 10-minute period changes, then the mean for 25-minute will also change. So basically the mean for 25-minute, or you can say 30-minute, it is basically dependent on the mean for 10 minutes. So we will consider the null hypothesis as lambda equals to what? 2. We will consider the existing one as what? True. Okay. So in this case, for part C, what we will consider? We will consider the null hypothesis for part C, H0. H0 equals to what? Lambda equals to 2, and H1 we consider what? The belief, the customer, not the customer, the manager, or the claim. Basically the claim or the belief we consider as the what? The alternative hypothesis. So in that case, they want to see whether it is increasing or not, right? I marked it here in the question. Definitely you have seen. They want to see what? It increases, right? Whether it is increasing or not. So that means, since they wants to see whether it is increasing or not, that's why it will be lambda greater than what? 2. Okay. Okay. Now for 25-minute time period, for 25-minute period, consider the variable, consider a different variable, consider you can consider it C. It's distributed C for customers. For 25-minute it would be what? 2.5. It would be, sorry, it wouldn't be 2.5. For 10 minutes it's 2. For 20 minutes it will be 4. So for 25 minutes it will be what? 5. Lambda would be what? 5. Poisson with 5. So C is what? Number of customers arriving in what? 25 minutes. Okay, this is what? C. Okay. Now the level of significance is what? 5%. Okay, now you need to figure out whether the test is one-tailed or two-tailed. Definitely it is one-tailed, because we need to consider only greater than, right? Since we need to consider only greater than, that's why it is what? It is one-tailed. Okay, so for one-tailed, what's the level of significance? At how much? At 5% level of significance. What we can write? At 5% level of significance, they got the, from the test statistic, they got the outcome. How many? How many they got in the question? Okay, in the question how many they got? They got, I think, 10, right? Exactly, 10 customers arrive at the garage to buy tires. Okay, 10. So C equals to 10. So let's see whether C equals to 10 it lies within the critical region or not. So in that case, let's find out probability of C greater than or equal what? 10. Okay, so it would be what? 1 minus probability of C less than or equal what? 9. So what it would be? 1 minus, okay, we need to check the table again. So if you check the table, okay, if you check the table, we need lambda 5, right? Okay, this is lambda 5. We need probability of probability of C less than or equal what? 9, right? This is what? Here it is 9. Okay, 9 goes towards this row. So this is 0.9682. 0.9682. Okay, so this is what? 0.9682. 1 minus 0.9682. So what would be the value? 1 minus 0.9682. So we'll get 0.0318. 0.0318, which is basically less than 0.05. So since it's less than 0.05, we are considering 5% level of significance. That means C equals to 10. The outcome of this test is basically lying inside the critical region. Okay, so C equals to 10 lies what? Within the critical region. Within the what? Critical region. So what we can say? So hence we will what? Hence the test is significant, right? If the outcome lies within the critical region, then the test is what? Significant. Hence the test is what? Significant. So what we should do if the test is significant? Reject what? H0. We will reject H0. Okay, so if we reject H0, then definitely the H1, the alternative hypothesis, was the belief of the what? Of the manager. Therefore what we can say? Therefore the test shows sufficient evidence to support that not that, you will write to support the manager's belief. Support the manager's what? Belief. To support the manager's belief. That's it. This is all about part C of the first question. That's it. Okay, now the last part, that is part D. What they have asked in part D. So in part D they said explain why the Poisson distribution is unlikely to be valid for the number of tires. What? The number of tires, okay, sold during a 10-minute period. Okay, so most of the students get confused in this part, like why, like the question earlier, the question said it is distributed Poisson, it is having Poisson distribution, but now the question is saying what? Asking why it is unlikely to be valid. So you will feel confused here. The fact is that the students, if you don't read this question attentively, then you will get confused definitely. So there is some change. Look, they are considering the number of tires here. Okay, since they are considering number of tires, earlier, let's see, earlier what was that? Earlier it was the number of customers. It was the number of what? Customers. So the number of customers that is arriving the garage, it can happen at an average, at a mean rate, right? But it's unlikely that all the customers will be taking on average the same number of tires, because a driver, definitely the drivers who will be arriving at the at the garage, right? They drives different type of vehicles, isn't it? They drives different types of what transports. So in that case, the transport which have like greater number of what greater number of wheels, it will require more tires. The drivers which who drives smaller cars, okay, they will buy what lower number of tires, right? Isn't it? Okay, so that means all the drivers will not be buying the same number of tires, or like the number of tires that they are buying, it's unlikely to be what happening at a mean rate. So that's why it is what unlikely to have a Poisson distribution. Okay, so what we can write in this context, we can say for part E, okay, so for part CD, okay, for part D, what we can write here, we can write here that part D, it's unlikely that the number of tires what the number of tires that will be, okay, the number of tires it's unlikely that the number of tires that, okay, the number of tires the customers buying would have a mean, right? You can write it on your own way. It's not like it's not like must be as me. The main concept is that the number of tires that the customers will be buying, it's unlikely to have a mean rate, or to have a constant rate. Okay, because it depends on totally on the preference of the customer, right? So what we wrote here, it's unlikely that the number of tires the customers buying would have a mean, or would have a mean rate, okay, or would have a constant rate. Okay, that's why it is what unlikely to have Poisson distribution, because for Poisson distribution the main condition is that the number of occurrence, it should be what at a constant rate. Okay, so that's all about the first question. The video is a bit long, since statistics, it's all about statistics. In statistics you need to explain like pretty much more. So if you you might feel boring to see this long video, so you can do one thing, like you can watch this video in by making it faster, 4 times or 2 times, it will be better, definitely. Okay, and that's all, and yeah, thank you.